Welcome back to Aquatics Live YouTube channel. Please like and subscribe and hit the notification bell and all that jazz. Hey guys, so I'm doing well, it's still for the this is for the my motorized trailer BattleBot deal that I'm working on. But this is more electronics side of it here. So if you're not in the electronics thing, then you know, I'm not sure, you know, you can skip this one. But essentially what I'm going to do is set up a conversion for, this is an ESP32 board here. This one has an antenna hookup for external Wi-Fi, which is something I want to have on there. And it gives me like a little smaller package to deal with, and I got this little breakout deal with the screw terminals on the sides here, so it's a pretty handy little unit. What I have found though is this outputs all the signals coming out of here are PWM, but they're 3.3 volt, and the controlling you know, the driver boxes that I'm running on here, they prefer 5 volt PWM signals. So I got this little adapter board here, a little tiny thing. But essentially what this does is it converts the 3.3 volt signal to 5 volt signal, or whatever you want it to convert it up to. One's a low side, one's a high side, and you just give it the new voltage that you want, and it'll convert it up to it. So it's a handy little deal. I'm gonna just hook up a cable for make this into the harness for it. But I'm just gonna kind of show in this video. We'll go through with one input and one output, and wire in the power wires, and show you how it works on the oscilloscope up here. So, so we'll kind of jump around a little bit with the showing the screen of the oscilloscope before and after. I'll put those images in there, and I will show you a close-up of this on my my little electronics microscope here, so you can kind of see what the board looks like, so you know what I'm doing. Essentially, there is a total of 8 I/O, or 8 connections that need to go through this board, or to the system in general. And this is a it can do 8 inputs and outputs, so it's a kind of a perfect little match for it. The package I got, I just ordered it on Amazon, so there's extras. So I may I will keep the extras with it, so I know in case this does go out, I can just swap in another one. But I'm gonna kind of go through that process, and we'll jump in here in a second, getting the next pieces together to kind of show you what I'm going to do. So here we go. All right, guys. Okay, so I got the scope set up here. I'm going to put the like zoomed in little image on the deal here. So I'm going to get the recording set up here, and get this started here. Okay, so I'm gonna, so you can kind of see now in the image, we got the VB, it's up here. That's the outgoing voltage, so that'd be our 5 volt signal. And then up here in the, there's the ground position over here to the right. And that's going to be our, you know, the ground for, that goes for both of them, so they're a common ground. And then down here in the bottom left, we have the VA, which will be our 3.3 volt signal voltage. And then we have all our A reference, so these will be all the inputs going into it. They're bi-directional as well. So if I do need to feed something back into the ESP board, it can go both directions. But in this case, I'm just going to say these are the inputs and these are the outputs on the top here. This bottom corner here is called the output enable pin. So this pin over here, let me pull this out. I'm going to go ahead and stop the video now. And I have a kind of written out on this little piece of paper here. So what I'm going to do is I'm going to kind of explain this a little bit. So here we got our ground up here. There's our output enable. So the tech documentation from Texas Instruments states that you should have a pull-down resistor between ground and that output enable. So I'm putting a 10K, so 10,000 ohm resistor, really high value. And then when the system comes alive, we need a way to turn it on. So this essentially is holding it to not be working, or disabled anyway in this position. When we do have power coming into it, which will be my A voltage here, my 3.3 voltage. When voltage is applied here, we need to enable this pin. So I'm putting a lower value, still high, it's a 1K resistor, but this will apply voltage to this pin and turn it on. And then all my outputs and inputs are activated. And then here's my 5 volt up here. That one doesn't go to any of this stuff. I just kind of put it up there so you can kind of get the reference between that image little video I did of the board and how these are going to go in. I have some resistors for that, so they're pretty tiny, so that's why I drew it out. Anyway, so we'll get back into here now. I have the wiring ready. So I just got some short lengths of wire I'm going to do 2 inputs into the board with these, and inputs to go from between this little board and here, and then these wires is I got my 5 volt positive. This one's going to be my 3.3 volt positive here, and then this will be the ground, and that'll feed this little board so with its voltages it needs. And we'll get that kind of soldered up together here, and I'll show you it all hooked up, all the wires kind of soldered in and hooked up to this board. The other thing going on is on here, what I did is I just have a couple of these pins on here. They're going to just be pulsing and on and then pulsing off. So I don't know if you know the Arduino stuff, it's like the blink sketch essentially. I'm just doing 2 different pins on here and blinking them on and off with like a 100 millisecond delay between them, so they can keep going, and then we can see them on our scope up here. So that'll be kind of the fun part. Once we get it all hooked up, I get to see the differences between the pulses coming in. So looking forward to that step. And then that'll kind of get us a stepping stone for the next part, is getting these wires ran onto the robot here. I didn't want to just, I've been testing with it, but I do need to get the wiring set up. But this is part of it, so I wanted to make sure I kind of showed the process of how I'm working around some of the limitations and making this work. These drivers that I'm using are cheaper ones, but they seem to be working well. And maybe in the future I won't need anything like that, but for right now, I'm making it work with what I got. So, and these little boards here, this is they're super cheap, so it was an easy process to get this set up. And I will put the link to this, the Amazon link to this in the description, and the Amazon link to these 3 items as well. So you kind of have, you can essentially follow along if you want to do something similar to this. I'm just kind of showing my process. You know, hopefully it helps others. Anyway, it kind of got me a little frustrated when I wanted to when I wanted to switch to this ESP32 board. I realized that, oh, I can't just wire in the motors direct in the signals into this. I have to go through a converter. So showing that process. Anyway, thanks guys. Okay guys, I get this all wired up here. It's pretty messy. I don't know if I can really show this on, well, I'll kind of tip the camera down here, and maybe you can see that's it's pretty much chaos on the bench here. So there's the board. I got all the wires kind of wired up. It's kind of a mess, but the point is I'm going to show you up on the scope up here what's going on, and I'm grabbing some screen captures up there, so you'll be able to see it, of course, better. But essentially we got, I'll turn these both off, and so we have on channel 1 is our 3.3 volt signal up on channel 1. And I'm going to grab a screen capture, grab it to the SD card here, or I'm in the USB. And then, so that's the signal coming out of the ESP32 board. Then, turn that one off. We have our, now we got channel 2. And that's our output signal. This is at the 5 volt level now, and so it has a nice pulse. I'm going to grab a capture of that to the card here, and then we'll do a combo of the 2 of them, and hopefully these screen captures grab correctly. But it's also showing our frequency is proper. These are 100 millisecond sections on here. So that's all good, and it's showing our difference. Our signals match right up. The yellows are 3.3 volt, and the blues are 5 volt. So we're getting all that going here, and so I got all these captures in here, so you should see them as I'm doing this. I know it's a little messy, but that's kind of how the wiring goes. It gets kind of messy a little bit. So, but I'm glad the little board's working. It's got all let me unhook the power from it, and maybe I can kind of undo a few of these wires here, and kind of see that way you can see a little bit better. But so on our little board here, we have this is our 10K pull down resistor, so it's just going between ground and our enable. This is our 1K enables wire that's going from our positive over here to here. This enables it, and then our 5 volts on the top. Our 5 volt and 3 volt are on these top 2 wires. So anyway, I think that pretty much covers it, and this gets us going on this gets us going for the brains to the robot, essentially. Yes, I'm going to be able to override it with the RC controller, so that's still fun to drive it around like as a big giant RC car, and enable and disable attachments and things that we have to put on there. So say we want to clean up some brush around the yard or something, we can kind of drive it around with the weed whacker or some type of tool on there to help clean things up, or I don't know, but I'm hoping to make it kind of versatile. I mean, the basics are to get it so it can drive it around and it can move things for me easily, and make it into my little trailer for my bicycle and things for adventures, for going camping and things. So yeah, that's the deal. Is I just wanted to get the kind of the brain going and kind of get you intro of what I'm doing over there. So thanks, guys.